This video will help you understand problem 1.1 in looking for Pythagoras. In this problem, you're given a map of an imaginary town called Euclid. On the map are certain locations that are important to the city. In the center of the city is a city hall at the origin, as everything in this geometric city is based on the coordinate plane. The big ideas in this lesson are finding locations on a map and finding the distance between 2 points in a geometric plane, or 2 points on a map. We will specifically look at driving distance versus helicopter distance in finding how long or how great of a distance it takes to get from one place to the other. Let's start by finding a location on a map. Remember that when we're working in the geometric plane, we use an ordered pair to describe where a point is located, and that is an XY pair of values. First the X coordinate along the horizontal axis, and then the Y coordinate along the vertical axis. So if we look at the location of the art museum, starting at the city hall or the origin, we have to go over 6, and then we have to go up 1. So the location of the art museum is 6, 1, and we write that in parentheses to make sure we know that that's an ordered pair. So the next idea is driving distance from one location to the other. And in the driving distance, you would have to stay on the grids on the map, the horizontal or vertical lines. So let's imagine that we were driving from the cemetery to the animal shelter. There are a number of routes that we could take to get there, and some have a shorter driving distance than others. So when giving driving directions, it's important to tell a person which direction to go. Saying 2 blocks left doesn't really help us because we don't know which way we're facing, and saying 2 blocks up doesn't help us because we can't jump 2 blocks in the air. So the directions on the map are important, and most maps have some kind of indicator of where north is. On this map, it's up in the left-hand corner. So if north is that way, then we also know where south, east, and west are. So that I'm going to drive from the cemetery to the animal shelter. One possible route would be to drive 2 blocks north and then 3 blocks east. So there'd be 2 blocks here, 3 blocks here, and so that would be one set of directions. An alternate route would be to drive 3 blocks east and then 2 blocks north. Now there are numerous other routes, but when we're looking at driving distance, we want the shortest driving distance. So it's possible I could drive from the cemetery, 4 blocks north, a block east, 4 blocks south, another block east, 4 blocks north again, another block east, and then 2 blocks south, and I would arrive at the animal shelter. But that obviously wouldn't be the shortest driving distance. So what we're looking for when we talk about driving distance is the shortest driving distance to that point, even though there are many routes that would give you the shortest driving distance. So the next idea is, what is the total driving distance? Not just the directions, but the total driving distance. So if we look at that first route where we went 2 blocks north and 3 blocks east, we have a total of 5 blocks as a distance. Now our other route where we went east and then north was also 5 blocks. And what you'll notice is we take alternate routes. For example, if I went 1 block north, 1 block east, 1 block north, and then 2 blocks east, that will get me to the animal shelter, and if you count the distance, it would be 1, 2, 3, 4, 5. It would still be a total of 5 blocks in driving distance. So there's many routes to get there in the shortest driving distance. Now if we blow that up a little bit so you can see it in a larger scale, the next thing we look at is, what if I was to use a helicopter? What if I flew from the cemetery to the animal shelter, and what would happen to the distance? Obviously with a helicopter, I'm not confined to the horizontal and vertical lines on your grid like the streets on a city map. so I could fly as the crow flies straight from the cemetery to the animal shelter. And that's a math idea, that the shortest distance between 2 points is a straight line. So we're considering what is that distance. Now we can't measure in city blocks because the diagonal distance is different than the horizontal or vertical distance. So for example, if I outline a city block up here in the left-hand part of the screen, if each of those sides of that square was a block, the distance across the city block would not be 1 block long. It would be longer than 1 block long. To illustrate this, you can take 3 straws of equal size and make a right angle with 2 of them and try to connect the other 2 legs of that triangle. Here's an example. Think about 2 straws like this where these 2 green lines are, and try to take another straw of the same length and connect those 2, and it won't quite stretch all the way across. That's because that diagonal distance is a little bit longer than that 1 unit. So when we're talking about city blocks, how do you measure that helicopter distance from the cemetery to the animal shelter? Well, in our book, this map is laid out on a centimeter grid. So each city block is 1 centimeter. So I could take a centimeter ruler and measure along this line to find out an approximate centimeter distance, which would translate to how many blocks it is. So I can't do that on this screen here, but we do know that the distance from the cemetery to the animal shelter is going to be longer than this distance here. It's going to be longer than 3, and it's also going to be longer than 2. But we also know that it's going to be shorter than the combined horizontal and vertical distance. It's going to be shorter than 5. So we can predict it's going to be somewhere around 3 or 4. Well, bigger than 3 and smaller than 5. So somewhere around 3.5 or 4, but we can measure to find out for sure. And what we learned from that at the end of the lesson, a big idea, is that the helicopter distance, if you will, the diagonal distance between 2 points, is always going to be shorter than the combined driving distance of the horizontal and vertical distances, except when the points are on a straight horizontal or vertical line. For example, if I had a point here and a point here, driving distance would be 3 blocks and helicopter distance would also be 3 blocks. But when there's a diagonal distance, it's shorter by helicopter than by car. Well, that concludes this video for looking for Pythagoras problem 1.1. If you have further questions, you can email me at this address.